same as when you get a positive, then that means the left and right hand side of the y-axis is the same. And that's an even function, like x squared or cosine. The symmetry of speaking of that, the symmetry of an even function is across the y-axis. It's line symmetry. There's two different types of symmetry. Lines of symmetry, students usually do much better than point symmetry, which is harder. Okay? To demonstrate a function is odd, show that when you put in a negative or the opposite of the normal function comes out. The symmetry of an odd function is about the origin. It is point symmetry, which is to say that if the distance to any point here on this side is that much, then the distance through the origin on the other side is exactly the same, and that would be true of this point, then this distance would match this distance. And so you get point symmetry. The distance between the points through the origin is the same on either side, so something like that. Yeah? All right. Try the first one on your own. I gave you a simple curve sketching problem first. Curve sketching is a huge idea of Calc 1. Try it on your own. Oh, I like that. All right, ready? What does even imply? Symmetric about to the y-axis, yeah? And what kind of region are they giving us about? X less than 0. What do you interpret that to be? The left side of the y-axis, yeah? Left of the y-axis, we know that f is less than 0. What does that mean? Y value is negative. Below the y-axis, the derivative is positive, implies increasing, and f double negative implies concave down. So below on the left side of the graph, y is negative, which puts me right away in the third quadrant. I need to show an increasing concave down graph. So something like that, yeah? Now it's even, so what should the right side look like? A reflection of that. So you should have something like that. Does it have to go through the origin? Could this be okay?
Yes.
Surely. In fact, it'd probably be better. Then it's actually definitely negative. So it doesn't have to go through the origin. It could be anything below there. You follow? Okay, try a little harder one. This was pulled from a CU exam 1. If you're going to CU, they have a lot of exam resources about past exams. You know, the first exam, which is heavy on limits, and the second exam, which is heavy on derivative technique. You could get a feel for what a college exam looks like, and usually worded slightly differently, and it takes you a second to interpret, but it's the same calculus. free to talk it over with your mathematics once you have your theory. Yeah, asymptotes don't have to be for both sides. Horizontal asymptotes, okay? So don't think you have to find that, reach that one on both sides. In fact, you cannot. It'll only be one side. That's a little tricky. How you doing? Please. All right. Let's go. Most people have the right idea. I walk through each part. Anytime they give you a point, I love that. I definitely know how to do that. So I have a point and an asymptote, and this kind of confused me after the fact, but that's all good. So wouldn't you agree that in this little region from 0 to 1, I'm increasing concave up? Okay. Now how do I know at the origin? Because later on they said the derivative is 0 there. Well, I can't have a derivative of 0 at x equals, Actually, if it's symmetric about the origin, does it have to pass through the origin? That's kind of how I know that, yeah? Yeah, it kind of does. It's not like I can pass up here and be symmetric at the origin. That's not going to happen. So if it's symmetric about the origin, usually it will pass through the origin, right? So, and then decreasing concave down, or concave up. So does the right side look something like that, yeah? And then the symmetry means that it should be doing roughly the same thing over here, but on the other side. So there should be an asymptote at -1, a point at -1, -2, and then decreasing concave down and increasing concave up. Something like that. We? All right. Let's go on to some ideas again. These should be review. I hope they're review, but we'll make sure. If f is even, then what would you know, or what could you tell me about an integral that's symmetric about or symmetric about 0? From -4 to, or negative b to b would be 2 times 0 to b. That's true. What does that mean, aid? What is this there for? Oh, I got you. Okay. Let's assume A is less than B and both of them are positive. Okay. So what could you tell me about an area on A to B and how it would relate to an area on the other side? Think symmetry. It would be the same as or opposite sign, first of all. Same. It's above and above or below and below because there's symmetry, okay? And then the question is, surely the bounds are going to turn negative now because we're on the other side. The only question is it negative A to negative B or negative B to negative A? Yeah, there's that symmetry. Follow? Okay. If f is odd, then what do you know about an integral from negative b to b? Has to be 0. If it's symmetric about the origin, then you must have some positive and negative area situation on either side. It has to be 0. This is a subtle, I understand right now, oh, it's obvious, it's easy. The problem is it comes in a mixture of a whole bunch of problems, and you'll get something like this. Gosh, tangent cubed or something wacky like that. Um, that from negative 3.24 to 3.24, and it's no calculator. Well, what the heck? You're not supposed to integrate that. You're supposed to recognize, oh, that's an odd function. They got symmetric bounds, even if they're ugly. This is 0. Okay, so you need to have your eyes wide open there. It won't be that obvious. You'll be expected to use it. All right. What about if you had a region again with increasing bounds from A to B, positive? What would you know, or what could you conclude about a picture? Is very helpful. A negative sign. That it would be the opposite value of the integral from negative b to negative a. You got it? Okay. We talked about this a little. I put it in again because it didn't go very well in the test I put it in. Anytime f is bound, then you can talk about the area under f. For example, if f is above the y-axis, then don't we know that the integral or the area under f must be positive, yeah? Likewise, if the area, or sorry, if the curve f is above the curve g, then the area under f must be greater than the area under g. In other words, I could integrate each piece. Now you might think, well, what if these were negatives? So here's f. It's got to be above g. Would the area, would this still hold true? Would the area for f still be greater than the area for g? Why? Would these integral values be positive or negative? Yeah, it's a smaller negative. Okay, so f's integral would be a smaller negative, like negative 2, as opposed to g's area, which would be negative 5. Well, isn't negative 2 greater than negative 5? So it still holds true even if they're negative curves.
Would it be greater than or equal to?
It should be greater than or equal to, correct. Yes, thank you. You're right, Carlos. So given that, then if I told you f is some curve that is always above some lower bound L, where L is some constant, that's the lower bound, and always less than some upper bound U, then what could you tell me about the area under F from A to B? Seems like you can't tell me much at all. Okay, so the easiest way for me to do this is to think, if I know this is true, then the integral of all these is true. So I can integrate L from A to B. And I can integrate F from A to B. And I can integrate U from A to B. Are you with me so far? All right, now when I integrate L with respect to X, L is a constant. So what is the antiderivative of L? Lx from A to B. The integral in the middle is what we're trying to establish. We don't know anything about that still. And what is the antiderivative or integral of U? Ux from A to B. Okay. Now with that said, do these A and B go in for L or X? X. Okay. So when they go in for X, do you want to get something like L times B minus A? Are you with me? And U times B minus A. So the integral would have to be between those two. Now, That's great. It's analytical and it's true. Let's talk visual. What is this? This L times B minus A, what does it mean graphically? Nothing, huh? What is B minus A? That's this distance, yeah? And L is, so L times B minus A is that area of that rectangle. Is the area under that blue curve greater than that area of that rectangle? Yeah, for sure. Okay. What about U times B minus A? Well, certainly B minus A again is this dimension times U. That means the integral is less than that area. And I think that is obviously true as well. You with me? Okay. What do you think analytically or graphically is up to you, but I want you to at least understand one of the two, preferably both. All right, would you practice these 3 AP style questions, and let's see how they go, and we'll go over them in a bit, and then we'll be done. Please do not just throw around 10s and 4s and 2s. I want actual calculus. See the rules in the bottom right as far as what I expect. Oops. How are we doing? What did you get for the first one? It is -6. Excellent job. Okay, the thought process that I have up here, first of all, I never deal with limits that are going the wrong way. The first thing I do is switch those. I do not like that. First of all, it just bothers me to look at. Second of all, it's going to lead to a negative dx question. So you switch those first. And then I hope you use the symmetry idea that The left side from -8 to -5 would be the same as the right side from +5 to +8. Yeah? And then eventually you did whole minus part equals other part. That's where -6 came from. Any questions on the first one? Cool. Second one. Can you just say, is this the same as -8 to -1 and then stick a 2 on later? Is that okay? No, it is not okay. You cannot just say, you know what, I'm not going to integrate 2. I don't feel it. You must integrate both. Yes? Okay. Did you separate first, then deal with the going to positive territory? Or did you deal with the go to positive territory first? If f is even, is f plus 2 still even? Justify why you say it. I agree, but tell me why you say it. What does plus 2 do to the graph? Okay, so if a graph that was even, say this is f, do you agree that's even? If you shift it up 2, I think you'll agree that that does not ruin even. It's still even, yeah? Would plus 2 ruin odd? It would, very much so, okay? But it doesn't ruin even. So whether you kept it together or separated right away is fine either way. So it sounds like most of you kept it together. So this is the same as the positive version of 1 to 8. And then hopefully you did 1 to 8 of f plus and still integrated 1 to f of 2. You down? 1 to f of 8 is, or 1 to 8 of f is 10. And the antiderivative of 2 is 2x. So what did you get for an answer there? 16 minus 2, 24? Yeah. Yay. Okay. And last but not least, wow, that's wacky. What the heck? If I see a product, what 2 things should you think? Ultraviolet voodoo or USA. Now, which one did you try here? Ultraviolet voodoo. You know, if this were x squared, man, okay, maybe USA. But it should be ultraviolet voodoo. So the question is, what's U or dV? What's a logical dV? F prime, because you could easily integrate dV of f prime to get a v of f. That means u must be x, and therefore du is dx. So with those components, uv is xf minus v du is f dx. Where you put the limits is always confusing for people, and if you just put them anywhere, you're good to go. But you do have to have them somewhere. Now, it's not just the integral that you have to put them on. It's also the whole. So this is, now I'm getting kind of wacky. This is x. Let's do this here. So I got to put in 5, yeah? So here we go. 5 times f of 5 minus -5 times f of -5, yeah? Now, let's come back to that. That's creeping me out. What about -5 to 5? What do you know about that? It'll be 2 times something you don't. Did I not give you that value? Oh, that sucks. What do 2 times 0 to 5, but I didn't give you 0 to 5. Did I?
It's not a rope, the integral from 0 to 5, not equal.
Don't we need to know this?
Yeah.
What was I thinking? If you don't know, how am I supposed to know? Let's call it 3. I have no way of knowing that, right? Do I have any way of knowing that? You sure?
I have no way
All right, we'll call it 3. I don't know what I was thinking there. All right, just want to make sure I wasn't missing something. All right, so what do I know about negative 5 to 5 then? Let's show some good calculus. Before I say it is a value of, oh gosh. Okay, so I guess we'll show the calculus first. What do I know of the integral from negative 5 to 5? It is 2 times the integral from 0 to 5, because f is even, right? You bet, Mr. Rickman, I'm with you. Okay, so what is f at 5? 2. What is f at negative 5? 2, because the function is even, the y values at the same, or symmetry, have to be the same y value. And the last we said that is 3, so I'm getting something like 20 minus 6, so 40. All right. I assume by your darn near comatose state that it's a Monday kind of thing, and that tomorrow will be better. And it better be, because otherwise we're going for a run tomorrow. You hear me? We're going to run the mile. If you're this dead tomorrow, we're running the mile tomorrow. All right. And by we, I mean you, because I don't run the mile. All right. Are you ready to go over the homework? Yay! Here we go. Is there a worse experience than running the mile? 2 miles? I don't know. Pretty bad. It's the worst. Okay. How did this go? Okay, so I give you a little notes here, but I gotta tell you, this question, this first 3 response, it's famous as the AP exam question with the lowest averages in the history of AP calculus questions. The average was below 1. Below 1. Yes. Now, I actually changed D. D had an inverse derivative question that we haven't done yet. So it's still a bit of a humdinger. This whole exam, this is a 2007 exam. Almost all the questions were hard. It was the worst. I'm so glad I didn't. It was really hard. If you failed miserably, welcome to the club. That's everybody. So no worries. Okay. Do write some notes. I prefer in ink so you know what you did wrong and your corrections are obvious. I will continue to say this. I said this earlier, but I'll say it again. In college, that's just a really good technique. If you make corrections in red to mistakes made, then it's easy to study for math tests. You look for the red. Anything that was in black, you must have done right the first time. You probably still know it, but it makes it easier to study your homework if you just look for the red and study your corrections. All right. So, in this case, why must there be a value of r such that h of r is negative 5? There isn't any freaking h here. So I don't even know what the heck is going on. But if you see, should there be a place where the function is, then you should think IVT. Now that's great, but you don't have any h values. So what should you do? Yeah, you should get some h values. Try h at what? What should I find? You should probably find, because they're talking about endpoints of 1 and 3, you should probably find h at 1 and h at 3. H at 1 is f of g of 1 minus 6. Let's work inside out. What's g at 1? 2. And now I put that 2 into f, so it's f at 2. 9, and 9 minus 6 is 3. So this h function, which I have 0 idea what it looks like, I have no idea, at 1 has a y value of 3. Okay, cool. Now what should I do? H at 3. That's f of g of 3 minus 6. Working inside out, I need g at 3. G at 3 is? No, not yawn. What is it? 4. Okay. F at 4 is? Negative 1 minus 6 is -7. Now again, I have no idea what h looks like, but it just went from a y value of 3 to a y value of -7. Can we infer that it must have had a y value of -5? Yeah. Okay. Now, I was kind of, I don't know. I'm not sure. I guess I could try and prove it, but if f and g are differentiable, does that imply, what's the necessity, what's the condition I need for IDT? Continuity. Does f and g being differentiable imply that h is continuous? Exactly. That's what I said. Yeah. So I'll just go with it, because what else am I going to do? So I'm going to go with, because f and g are differentiable, h is continuous. And so the next part of IVT is the betweenness component. What do I want to show happened between what? -5 is between. Yeah, and if you show h at this and h at that, I think that's really good quality work, but this is the bare minimum. -5 is between -7 and 3. But again, whoever was saying that was you. If you show h at this is 3, that's really high quality. This is where these numbers are coming from. But you need to show that betweenness component. That -5 you ask about is between the two endpoints. So by IVT, there is a R, I guess they called it, an R in 1 to 3 where h and r has to equal -5. How'd you do there? Did you make that connection? Good. That was not easy. So if you made that, that's good. At least you got a soft 2. I think that was 2. Okay? So you're already better than average. Way to go. Explain why there must be a value of C between 1 and 3 where, oh, shoot.
Yeah, you told us.
Oh, I did? Oh, okay. H prime at C is -5. Okay, so if you see a derivative, you should be MVT. Okay, there are 3 main existence theorems in calculus. There must be a place such that. And IVT and MVT are 2 of them. All right, so I'm thinking MVT, so great. That gets me started. Now what do I do? Check the parameters or the conditions for the use. Is H continuous on 1 to 3 and differentiable on 1 to 3 open? I'm going to say yes, because f and g are differentiable. Basically, a function with no monkey business and a function with no monkey business put together makes a second function with no monkey business. See down? I mean, if there's no asymptotes on the pieces, then there are not going to be any asymptotes on the composition. Okay, that said then, so by MVT, there is a, keep me going here, there is a C in 1 to 3 such that, or where, something like that, H prime at C equals,
F of G of
I'm going to say H at 3 minus H at 1 over 3 minus 1. Now I don't have to go find those because I just found them. H at 3 is, now obviously if you didn't do part A well, then part B is going to be hard, but H at 3 was -7. H at 1 is 3 over 2. That is -10 over 2. That is, thankfully, -5. Because if that didn't come out to be -5, then I would think, I don't get it. I don't know. Okay, you down? The average rate of change, whatever H looks like, the slope between the endpoints is -5. So there's got to be a place where the tangent slope is -5. You down so far? Okay. This one you might have done well. You might have a slight error in it. There is a chain rule component that most students miss. But let's talk about it or not. Maybe we won't get through this. Maybe we can. All right. Is W prime equal to just the derivative of this, so f of g. No, it is not, unfortunately. Okay, so let's go here. This is a no. Would you let capital F be the antiderivative of f, just to show you where this has come from, all right? Are you with me? Okay, so w of x, when I say it's the antiderivative from here to here, wouldn't I first find the antiderivative, put in g and put in 1? You with me? So given that the antiderivative is big F, w is big F at g minus big F at 1. So far, so good? All right, now w prime then, you can see why there's a chain rule component. W prime is the derivative of the outside. What's the derivative of big F, which is the antiderivative? Little f with g in it, but then times it over the inside, g prime. There's a chain rule component to that, minus 0. We'll finish going over that tomorrow. Have a great day. Make sure that it is not due. See you tomorrow.